to the Daily Grind. This is a podcast by Cutting Tool Engineering Magazine. It's a informal chat of machine shops and machine shop culture over a cup of coffee. If you guys notice, we're back. We're back at Acopian Engineering Center. Thankfully, the weather has held off after that cataclysm we had a couple weeks ago, or even last week. I was out 3 times with the snowblower and shovels, just trying to get us out of that crap. It was so much snow. So being at Lafayette, Lafayette offers an unparalleled engineering curriculum to put you ahead of the pack when it comes to getting your first job out of college. So if you or someone you know has a high school age student looking for an engineering school, please, I advise you to say Colonel or why not and join us here at Lafayette. Now, that's also to say that all of the skilled trades, if you find yourself needing to be somewhere or needing a change of pace in work, the skilled trades would love to have you. So let's make our first cut of the day. Today, speaking of coffee, we have my new favorite. It is the Strange Animal Brew by Blackout Coffee Company. So it's very good, very, very good. I suggest you get some. Today, we are joined by Ron Cook of Fullerton Tool Company. These guys make off-the-shelf end mills, and they make very custom cutters. And we'll dig into all of this as we go. So, Ron, thank you very much for joining us today.
Thank you. It's a pleasure to be here.
As with all my guests, let's start with a brief backstory. Who are you? How'd you get here? What's your title with the company? Dig into you, please.
Right. Well, as you mentioned, my name's Ron Cook, and I am in applications design and R&D in production. Pretty much have my hands in a few different areas. I started off back in the early 90s in cutter grind, making carbide cutting tools for a company that did not have any CNC equipment. So it was all done by hand and by hand machines, air bars, Keller grinders, and such. So I learned about cutting tools, and then after a few years of doing that, I decided I wanted to get into machining. So I went into machining and took some Mastercam courses and started machining for a medical instruments company. Did that for a lot of years, working in their prototype department, doing a lot of anything to work on the skeleton for cutting on the bone. So after a few years of doing that, I went into aerospace and did that for a year or two, and then found myself drawn back to cutter grinding again. I just love making carbide cutting tools and helping out manufacturing.
Wonderful. So we mentioned your company, your employer. A shameless plug for them. Who are they? And what is their bread and butter? What's their specialty?
Fullerton Tool is your complete go-to for round carbide cutting tools. We make just about anything you would need for a mill or lathe, from boring bars to burrs and reamers and special cutters, drills, end mills. Just about any type of tool that you need, we can put together. Custom one-offs. We do pretty much the whole carbide thing.
So right before we went live today, you were showing me a few samples. Do you still have them?
Yes, I do. This is one that we recently developed. It's called the VMAC, and it is a tool that's designed for cutting Inconel. Inconel is a tough material that a lot of the guys are after nowadays to try to figure out how to cut. And so we've developed a tool through rigorous testing in the R&D lab that cuts the Inconel really well. It's a full actual tool, so it's designed to go full depth with 10% radial in HEM machining. So it's a high efficiency tool, and it's really taken off well in Inconel. We're having great success with it.
You developed a high efficiency cutting tool for Inconel. Now, you mentioned to me an R&D shop right at Fullerton Tool. So how much fun must it be for those guys to push those things as hard as they can to see where they break?
Yeah, we really enjoy pushing them to their limits, trying it in different materials to see exactly how it works. But Inconel was the main goal, just because everybody's having such a hard time cutting it, that we really took a lot of time and a lot of hours running it through material testing to see how long it would last. We want to make sure that we can give the customer the biggest bang for their buck when it comes to the end mills.
Oh, man. So now, again, we were talking briefly before the show started. You had saved a company who will remain nameless. Did you say $780,000 a year?
Yes, yeah, there was a customer that came to us with a problem. They were, well, it wasn't really a problem, it was just a manufacturing idea. And what they were doing is they were turning their part off in a, I'll show you the part here. This is a custom milling cutter.
Look at that mirror finish, folks.
So what they were doing is they were turning it out in a Swiss style lathe and they were parting it off and they were introducing it to a milling center where they used multiple tools to mill this shape into their part. We developed this tool to go right into the live tooling bed of their lathe. So when they turn the part off, they can actually mill that form in before it's parted off. And that did away with the milling center and saved them, yeah, up to 700. I think it was around 780,000 a year in manufacturing, but also opened up the milling center for production. So you know you're saving more there. Whoops, I'm sorry, I lost the audio. Nope, I've lost the audio. I'm sorry.
How about now?
There we are. We're back.
Ah, something happened. We had a little button click. All right. So I had given it the colloquial term of the soup to nuts approach. And also, you had mentioned, was it 18 special different coatings you guys offer for your cutters?
Yes,
Yeah.
yes. There's different coatings for different applications. You know, some guys are running wet, some guys are running dry, some are using air blast, and it's all material specific. So when we develop a cutting tool specifically for a material, there's a lot involved. There's complex geometry involved and dispersing heat and dispersing harmonics. There's also an edge prep. You know, we'll take that tool after it's done, run it through a honing process to get just the right edge on the end mill for the material that we want to cut. After that, it goes to the coating center and would get coated for the desired coating, depending on what you're cutting.
Wonderful. Now, we had talked about you, as in Fullerton Tool, being an applications engineering firm where you had somebody with a manufacturing problem. You brought the job, or at least a prototype, in house, developed everything from the speeds and feeds to the cutters, and sent it back to the customer. Let's dig
Yeah,
into that.
sometimes in our R&D lab, we'll get a job where a customer's having problems with a specific application, and we'll try to mimic their application. If we cannot get one of their parts to actually set up, we'll actually develop one of our own, but we'll try to mimic their setup in our mill and we'll develop a tool for that operation. That way it cuts properly and we'll do our testing to make sure that, we can give you feeds and speeds for said tool and how to run it to complete that application appropriately.
Now, I realize that the material and your speeds and feeds really don't change with the make of machine. But have you ever had a problem where all the information you sent to somebody turned out to not work?
It depends, yes. And some places have really nice equipment, some maybe not so nice, where they're not as rigid as some. And so if we do a test and we find that our we try to build our setup around what they have. So if their setup isn't really rigid, we try to kind of come up with some feeds and speeds that would work out for them. It all depends on the machine. There's so many factors involved. But usually when we get with a customer, we try to find out what their needs are and duplicate that so that we can give them something that'll work perfect.
Now, I wrote an article for Cutting Tool Engineering a few months ago about tapping aluminum. I realize you guys probably don't get into tap making a whole lot, but my point was in all of it was to never take the aluminum for granted. Have you ever come up with a special cutter for even softer or easy to machine stuff that people were having trouble with?
Yes, yes. There's so many different materials. Aluminum is one of them, or if you're not careful, your end mill will pack up and you'll end up with a round ball of aluminum on the
Oh
end of
yeah.
your end mill. So we have we've engineered special geometry into our end mills for aluminum that helps get that material out of the flute, and that works pretty good. There's so many different materials though, then we have so many different applications that It depends on what you want. We can build a cutter around that material.
Wonderful. So have you guys got into the composites market? I realize that in not so much in aerospace,
Yes.
but in a lot of other industries. I'm sorry,
Yes,
composites
yes.
are.
We've developed tools for composites. We've developed tools for plastics, for different types of styrofoam, even. I've even developed a tool for cutting clay. You
All
know, a
right.
lot of manufacturers in California, they have those big rooms where they build the big clay cars for checking
Yes.
for aerodynamics and stuff
Yeah.
like that. Develop tools for that. So when you're trying to develop a tool for cutting clay, I mean, how do you go about that? There's so many different things you need to look at, and having the expertise of many years. Fullerton Tool has been in business since 1942, and they've pretty much come up with a tool to cut just about anything.
Whoa. Have you? Well, I'm sure you have. Have you been big in the titanium market?
Yes, yes, we have actually a line of tools that cut titanium. They're called our tie cutters, and so we have many different options depending on your application, many different flute counts and whatnot. And there's different types of titanium. What type are you cutting? Some of the coatings would work better for, different types. So there's all kinds of factors involved in the type of metal that we go to cut. How much this is in the metal and how much of this is it really abrasive. So there's just a lot involved.
Wow. So to kind of boost Fullerton a little bit and give you some marketing, we actually have a couple of your Aluma mills in our little bag of tricks. So I don't know if I told you when I spoke with you last week, Ron, is here at Lafayette, this is a prototyping shop. So we don't really necessarily stock rooms full of cutters like a lot of big industry does. We
Right.
mostly order for the job. And we were on MSC, which I think you said you distribute through,
Yes.
and we chose your aluma mill for its properties, and it's served as well. I've had that same cutter for. This is going to make some people laugh. I've had that same cutter for 7 years now, and it's still not even showing any wear.
Yep. That's probably the 3833 Aluma mill. And that,
38 214 or 38 241.
yeah, it would have been a 3833, I believe.
Okay.
Yeah.
So this one has it's a bull nose. I don't know if that changes anything.
Ah, yes. If it's a bullnose, that means it was probably a special,
Okay.
something we would actually stock on the shelf. But we have our 24-hour reamer turnaround. So if you need a special size reamer, we have a 24-hour turnaround on that. We have a special 48-hour altered standard program that you can call or even go onto our website. You can go onto our website at fullertontool.com and see exactly what we have in stock. And with a couple of clicks of the button, you can have an end mill, a drill, or whatever you need being sent to you. So you don't even have to talk to anybody. You can just click and it's on its way.
So everybody listening and watching, the link to their website is actually in the video description now. It is fullertontool.com, yes?
Yes, it is.
Oh, there you go.
Fullertontool.com.
There is your one-stop shop. Now, I realize it's a couple months from now that I'm going to be getting into turning. Do you offer inserts as well?
No, we do not. We are not
Okay.
into inserts. No.
All right. So it's strictly a milling side.
Strictly milling, drilling, reaming, boring, uh, tools for the lathe and for the mill. And we're really good at our engineering department is really good at putting together special tooling. If a customer sends in a print of a part and he
Yeah.
says, I need a tool to do this section and a tool to do this section. We might even be able to figure out a tool to do all of those sections in one shot. So that way it saves, in your mill, you only have so many spots for tools. In your
Yes.
lathe, only so many spots for tools. You want to get as much as you can done in one operation. That's the way I used to machine anyway. So the more you have available to you, the better off you are. With the development of different porting tools, that really helped out, the automotive industry and aerospace industry. Instead of sending multiple drills through and a boring bar and then something to tap for a fitting, we can design a tool to just go in there and in one shot, boom, boom, you have all of your bores and everything all set in one shot. So
Wow.
there's so much that we can do nowadays. If we have access to blueprints and access to designs, we can come up with tools that'll save you time and money.
Excellent. So toward the end of our interview today, I'm going to give you the stage. It's Fullerton Tool stage. Is there anything new without giving up too many ghosts, I realize there's proprietary information you can't let out. But are there any new developments or any new products out that you wish to announce or share?
Yeah, well, we're in the process of developing another tool right now, which is called our high wrap ball nose tool. And what it does is it works really good in abrasive material, and we're starting to work on other materials as well to come up with a good design. It's funny how back in the day, a hand ground end mill back in the 40s worked so well because it wasn't equally spaced. It was just hand ground. This, one tooth is different than the next tooth. So it worked really well for dispersing harmonics, dispersing heat. And then came the CNC industry, and everything started going together equally and perfectly. And they didn't quite work as well as the old style end mills. So we had to go into developing how do we make these end mills with unequally indexed and different spirals on each tooth and different things to disperse harmonics, disperse heat to allow the end mill to cut and last so much longer. We're really good at developing those type of scenarios. But if
Very
you
cool.
whatever, we make different types of saws. We had a guy that was burning up little 1/8 inch. We were selling him little gear cutters. He was trying to cut gears.
Yeah.
And he was going through those 1/8 inch end mills like crazy. Well, we developed a saw that had 60 teeth on it that had that form in it. So all he had to do was turn his fixturing 90 degrees, and he was able to run that saw through there for forever, not wearing out end mills, not tearing down his setup, and able just to produce and produce. So Fullerton tool is really good at coming up with scenarios and ways to help you in your manufacturing process to save time and money.
Oh, it's wonderful. So one of the other things I like to do when I have guests on from manufacturing companies is ask them, what is the craziest thing you think you've done? Are you allowed to give away certain names or certain aspects?
Some of our favorite, so at least one of my favorite projects was a project I did for Boeing, and it was a tool that was designed to hold the. If you ever look at a jet engine, it has got all those blades sticking off
The
the end,
Blitz.
spin really fast. We developed a tool to go in and cut the slots to hold those in place. And the tolerances were so tight that you weren't even able to check it on a comparator at 50 power. We had to use our specialized computer to go in and scan it, do a full 3D scan to make sure that everything was to print because, the parallel call outs were within 3/10 of each other. And that's on a helix. So it makes it extremely hard to check. And then, there was I love tight tolerances. We have what's called a Healy check, and we run Walter grinding machines with Tool Studio. So if I produce a tool that I can't check, I take it over to the Healy check and put it in there, and it does a full scan of the tool and tells me exactly what's in and exactly what's out. And if I want to, it will actually make the changes in the machine for me to
Like
correct the part.
touch up the.
Computer computer talking to computer. So it takes the guesswork right out of it. Instead of having to sit down and do complex math to figure out how far to move this, the computer takes care of it for us. So you're getting
So
the right tool.
wonderful. So for those listening and watching, a couple weeks ago I had Mr. Dave Winslow on to discuss Industry 4.0, and what Mr. Cook just explained with computer talking to computer is exactly what that was meant to do. Take take all of the guesswork and essentially human error out and give you exactly what you want.
Yes, Industry 4.0 is definitely a part of our manufacturing process over here.
So have you implemented that so you can take an idea, send it to one machine, and right down the line and come up with your final product?
It's possible, yes. Yes, it is. That's possible. Yep.
Well, Ron, cutting tool engineering, and I cannot thank you enough for taking the time to sit down with us today, especially
No
on
problem. It was a
maybe a busy
pleasure.
Monday.
You too. Thank you so much for your time.
Have a wonderful day.
You too. Thank you.
So, to all those watching and listening, that was a visit to Fullerton Tool Company and Mr. Ron Cook. We want to thank him very much for his time and taking the time to explain all of their options for us. If you are looking for a either an off-the-shelf end mill or a custom solution to a problem you're having, I strongly suggest you go visit them. Website is in the link to the website's in the description of the video, and we will see you guys next week. Tune in, same time, same place. This has been the Daily Grind. So may the only daily grind you face is the coffee in your mug. Thanks, everybody. Bye-bye.